Now here's an interesting problem. If you're given that the secant of theta is greater than 0 means it's positive, the secant is positive, and the tangent of theta is less than 0. To be less than 0 means to be negative. Okay, so in other words, we're told secant is positive and tangent is negative. Then we're asked to find the quadrant where this angle theta lives. Well, to answer this, all we really need to see is all students take calculus. So here is our all students take calculus. Okay, now why did I choose C? Why did I choose the fourth quadrant? Well, I chose it because the C is in that quadrant. And what does that indicate to us? That only the cosine and its reciprocal function secant are going to be positive in this quadrant. Anything else, any other angle that terminates in quadrant 4, it's quadrant 4, is not going to be positive. Okay, so the reason we chose quadrant 4 is because in quadrant 4, the cosine is going to be greater than 0. It's going to be positive. And if the cosine is positive, that implies that its reciprocal function secant of theta is going to be positive. That's one of the conditions. And the other condition, tangent of theta, well, heck, only cosine and its reciprocal function can be positive, so the tangent has got to be negative. So yes, that is the correct answer. The answer is the quadrant for theta with these conditions that were given is quadrant 4. That's the Roman numeral 4. You can use a regular number if you'd like. Let's do it again. Given that the cosecant of theta is greater than 0, it's positive, and the cosine of theta is less than 0, it's negative, find the quadrant where theta lives. So again, we're going to draw our quadrants and we're going to label them all students take calculus in a counterclockwise direction. All students take calculus. Okay, now think. Where is the cosecant going to be positive? Well, the cosecant is a reciprocal function of the sine. That will happen in quadrant 1 and quadrant 2, because in quadrant 1, all of the trig functions are positive. But in quadrant 2, only the sine and its reciprocal cosecant are going to be positive. Okay, so it's either quadrant 1 or quadrant 2 at this point. Now look at the next condition. The cosine of theta has to be negative, less than 0, negative. Where does that happen? Well, it certainly doesn't happen in quadrant 1. It does happen in quadrant 2 and 3, because only the sine and cosecant are positive in those quadrants. But the one that meets both of the conditions simultaneously is quadrant 2. In quadrant 2. That's why I circle it. And the reason is because in quadrant 2, that's in Roman numeral 2, the sine of theta is greater than 0. In other words, the sine of theta is positive. That implies the reciprocal function cosecant of theta has to be greater than 0. That was one of our conditions. And we also needed for the cosine of theta to be less than 0, and that's true in quadrant 2. It is not positive in quadrant 2. Only the sine and cosecant are. And you'll notice that we use the idea of reciprocal functions to answer these questions. So you can go back and review note number 142 to remember how that's done.